Okay, so I'm going to cover the k-means clustering today, and there's a lot of mathematical background. It's kind of required to completely understand this topic, k-means clustering. However, I try to minimize and the covering the mathematical aspect of this topic, right? However, I cannot just completely ignore them, right? So the mathematical concept is kind of important. So I know it's hard to strike a balance, right, between the theoretical aspect and practical one. So, but I'll do my best. Okay. So first, I like to talk about the supervised learning and unsupervised learning, right? There's the categories, right, in machine learning. The one is called supervised learning, and another one is called unsupervised learning, right? Okay, great example of the supervised learning is regressions, right? And there's something called the classification, but the regression is a really good example of supervised learning, right? So in our earlier discussion of the regressions, right, so basically if you think about it, right, we have correct answers, right, and then we train the model, right, from the correct answers, from that is correct answer in our case is trained data, right? So basically we have a training data set, the correct answer, right, and then we use it to build a model. And so after we build a model using this correct answer, right, the training data set, and then we finally compare the models in the predictions. So from the model we have a predicted value, right, on the data set, called X test, right? And we compare that with this prediction, right, predicted Y value with a known correct value. So remember we have a training data set, right? And then we have a test data set, right? So in the test data set, right, we are able to get actual observations, right? And then which is correct answer, right? Correct value. We consider it as a correct value, and we compare this predicted value with the Y test, right? This correct value of the, by the way, target attribute, right? So this target attribute meaning it's like response variable, dependent variable, or it's called a target variable, right? So that's the supervised learning. So the key words in the supervised learning is correct answer, the correct, right? And then the target value, so we have a dependent variable, target variable, and response variable, right? Okay, so that's like a keyword in the supervised learning. By the way, this target attribute in this context, this is also called what is this called? The target attribute. I mean, the labeled labeled attributes. So in this context, right? So in this context, this attribute is sometimes it's known as labeled, right? Labeled attributes. Okay. Whereas the unsupervised learning, right? When you look at the unsupervised learning, the best example for the unsupervised learning is clustering, right? And then there's something called associations, and actually there's another one called PCA, the principal component analysis. It's like another great example of unsupervised learning. But today's topic is clustering, right? So it's known as a PCA. Oops. The PCA stands for the principal component analysis, okay, and ETC. Okay, so but the typical, right, the typical example is, of course, is clustering, whereas in the supervised learning, the best example is just regressions. Okay. Okay. So now, if you look at the unsupervised learning, there's a big difference. The difference is for the unsupervised learning. For example, there's no upfront correct answer. Okay. So in this case, we have a correct answer, right? So using the correct answer, the actual observations, we train the model, right? But in this case, I mean, there is no upfront correct answer, meaning that there is no upfront correct clustering that can guide this process, unsupervised learning process. Okay, so there's no correct answer. It's nothing. Basically, there's nothing. And then there's no label data. Okay, so meaning in this case we have a target variable, right? In this case we don't have any label data, so no target, no response, no dependent variable. Okay, so that's the uniqueness about this unsupervised learning, right? So today's our main topic is clustering, of course, right? So that's our main topic. Okay, so now what is a cluster analysis? I'll show you the one example of the cluster analysis. Okay. By the way, I'm going to show this result, but please do not pay attention to the code. This lecture I use the R, right? But you can use a Python, right? So this video lecture, right? I'm trying to introduce the concept of clustering. K means clustering. So do not please pay attention to the code. Rather, just look at the graph. Look at this plot. Okay, so hold on. No, actually, I haven't. Okay, so now let's say we have, just take a look at this data. Okay, just look at this data set. So basically, we have in this data set. You know what? I'll just maybe I should show you this data set. Yeah, just run this. Okay, so you know that this is like if you look at this data set, I know that it's small, I know it's unrealistic, right? Usually you have, in this case I have only 12, oops. I know in this case I have a 12 just data set, which is unrealistic, it's just too small. But this is good enough to show you the concept, right? The main point. Okay, so when you look at this this axis, y-axis, you have a height, right? And then if you look at the x-axis, it's an age, right? So you have an age and then height, right? And then this is the scatter plot, right? So this is the age, and then this is the height, right? And as you can see, we can make it two clusters, right? Once again, I know that this is unrealistic. Usually, the data is not this nice, but this is just lecture, right? So we can immediately see that we can have two clusters, right? You see that? Okay, this is like first cluster, right? So this is the first cluster, and then you know that we can have another cluster, right? Yes, so we can immediately see that there's roughly, right? So we can have another cluster, right? So in this case, we can easily see that there's two clusters, okay? And another thing is in this typically, right? In a cluster analysis, instead of using this data set, this actual data, right? The 65, 60, and this is, let's say this is age, right? Typically they convert and they normalize this data, right? Sometimes, in this case it's really nice. I know that this is ideal, right? Like 9 to 14 and 55 to 70, right? So this is okay. You don't have to really do anything, right? However, typically, right, it's better to scale this data, right? So sometimes, it's typically, there are many different the scaling method, but you can use a Z transformation, right? Remember the Z transformation? So you have x minus mean divided by the standard deviation, right? So you change this value to a Z value, right? And then let me just draw this using this after the Z transformations, right? So let me show the plots. Okay, so don't worry about the code. Just look at the the plots, right? Okay, so you know that now this is the height, it's z value, right? Z value for the height, and this is z value for the age. So it's -1 to 1.5. You know that it's the mean for the z value is always a 0, right? So you did the z transformation, but still, as you can see, this is like the cluster 1, and this is like a cluster number 2, right? So that's like a clustering, right? Okay. So, okay, good. Okay, so now, so now that's a cluster analysis, right? Basically. So the trade-off, there's something that you should know about the cluster analysis. The first thing is there's always a trade-off, meaning that we need to achieve a trade-off between the coherence of the clusters and the number of clusters. So basically that means wants to avoid too many or the too few clusters and need to seek high coherence or so that means low incoherence. Okay, basically this is same as low incoherence, right? And some of the square deviation from the mean of each attribute is called within cluster sum of squares. So basically this is called within SS. This is very important value, okay, within SS. And within SS really stands for the measure, right? Measure of incoherence. So this is important. It's not the coherence, incoherence of the cluster. Okay. Now, so what do you mean by? Okay, hold on. Okay, so now so what do you mean by within SS? So let me just explain more about this within SS, right? And I said within SS is what? Degree of incoherence, right, of the cluster. So when you look at this, let's look at the previous example, right? So let's say this is the first coherence, right? And you know that this is the second coherence, and then you have probably some average, right? So the thing is, for each observation, right, there's some distance, right? You know the distance, right? So the ideally, right? Ideally, you need to reduce this distance, right? Right? Ideally, and then also if you look at the second cluster, right, there is some average, right? Like the center is called centroid, but anyway, so this is like, let's say this average of this the data set, right? These cases, and then you can just draw the distance, right? And you minimize this distance, right, within this cluster, right? So that's really this value is for the within SS, okay, sum of squares, okay. So you need to really reduce this distance, right? So the smaller the within SS, the better, right? Right. So because that's the smaller within SS means that distance, right? The sum of all the distance, it's really small, right? So that means it's really good. That's really good. The result, right? Okay. So now let's take a look at the example, right? So in our example, we have two clusters, right? The first cluster, right? We calculate the within SS, okay? And just trust me that once you calculate this within SS, our value is 9.567, okay? But by the way, you don't have to know how I get this value for this class. I'm not going to ask you to compute this value, but when you compute the within SS for the first cluster, is 0.9567. Let's say 0.95, okay, roughly. So go back, right? So what is a within SS value? 0.95, right? 0.95, right? So that's a within SS. And if you look at the second cluster, right? The within SS is 1.08, right? And then, I mean, this could be 0.95 and this one could be in the first, but the point, it does not matter, okay? So I assume that this is the first one and this is the second one, okay? But let's say this one is what? The second cluster, right? The within SS value is what? Where's my pen? Okay, so within SS value is what? 1.08, right? So 1.08. right? So the total within SS, you simply add these two values, 1.08 and 0.95. And what is the value? The total within SS value is 2.3882. Remember, this is a distance, right? Smaller this value is, the better, right? So this is known as TOT within SS. Okay, this is like a TOT dot within SS. Okay, now you can compute the within SS for the complete data set. Okay, this means one big cluster. Okay, so when you compute the within SS for the complete data set, you have 22. Okay, so this 22 is known as TOTSS. Okay, so what does that mean by compute within SS for the complete data set? Okay, by the way, there's a typo. So compute within SS, okay, with the complete data set. So this means you have one big cluster. Okay, so go back. So one big cluster means I'm gonna use the red. So assuming that you have one big cluster, right? So you compute within SS. I know it does not make any sense, but that's like the total SS, right? And that value is what? It's 22. Roughly, it's a 22. Okay, and then so the blue one, right? Total SS within SS for the blue two clusters, right? So this is the total TOW. What is the value? Let's see. Go back. The TOTWINNS, right? So what is the value for that? Is what? Hold on, where's the blue, right? This value is TOTWINNS is 2.03, right? So you can see that there's a dramatic improvement, right? So so this creating, as you can see, creating these two blue clusters reduce the total within SS from where? From 22 all the way to what? 2.03, right? So that's why the creating two clusters are much better, right, than one big cluster. Okay, so that's the idea. Okay, so now in summary, I want you to like memorize this. Not memorize. I mean, when you look at this, like you don't have to really memorize. But anyway, I want you to know this. The meaning of this variable name TOTWI within SS really means the total of, right, the sum of within SS for each cluster, right? So that's a TOTWINSS. And TOTSS means just total, right? Total, or just within SS for the one complete data set. You can think as what? The within SS just for the one big cluster, the red one, right? Okay, so that's the so as you can see, by just creating these two clusters, we see that there's a significant improvement, right? So yeah, so the conclusion is creating the two clusters is really good, right? Okay, now next question is this. The next question is choosing the K value. Like the K means how many clusters. In our example, we can see, right? Immediately we can see that creating two clusters, right? It's probably ideal. Or maybe, okay, if you want to, maybe we can create the three clusters. Maybe then maybe, right? Maybe we can just, this is like one cluster here, and maybe second cluster, and then maybe third one. Something like that. Or 2 or 3, right? Okay? Maybe 2, maybe 3, I don't know, right? But, so the question is, right? The question is this, right? How do we know, oops, there's a typo. How do we know what value of the k to use, right? So that's the main question, okay? Then we can, we'll use, so for that, I think the best way to choose, when it comes to like choosing this k value, right? The best way is the plotting, okay? So in my next lecture, I'll just create one plot, right? And then I'll show you how to choose this k value, okay? So that's I'm gonna talk about that topic in my next lecture, okay? Thank you.